Okay. Hello, everyone. My name is Grace Mitri, and I work for Intel. I'm an IT community evangelist. Can you hear me? No? Okay. Thank you so much for coming today. I know it's during lunchtime. At 12:30, they will have lunch outside, so hopefully by then I'll be done, and you can grab lunch and we can continue with Q&A. I'll be here at least till 1. So during today's talk, I'm going to talk about Intel Joule module and how you can design faster, prototype easier, and invent more. Has any of you seen the Intel Joule before or heard about it before today? Yes? Okay, I'm not surprised. We launched the Intel Joule on August 16th during IDF. So during today, I'm going to give you a quick introduction about accelerating developer time to market. And then I'm going to talk about the Intel Joule architecture and base carrier reference. Then I'm going to talk about how we can do lowering the barriers even more with an ecosystem for Intel Joule. And then I'm going to talk about our future engagement with Capital Factory. Okay. So I'm sure lots of you heard about the Edison. Basically in 2014, Intel introduced Intel Edison, and as a product with great performance in a small form factor, we've done at least one hackathon a week, I would say, since then. We do hackathons, we do workshops, we have tons of projects shared. And from all this, we have learned from and seen the need for additional capabilities. And why we love the makerspace, making Intel products fun and easy with products like the Edison, we are also translating fun and easy to the product advanced embedded computer innovation space. So we wanted something more capable than the Edison. And these high performance, so we checked the market, and these high performance growth markets, for example, in machine learning, such as robotics, they need a new class of products that is equal to the task. And so our objective was, we had a few objectives. The first one was making performance ubiquitous. And what we meant by that is we wanted to have high performance in a crazy small form factor, which opens new possibilities. Can you all hear me well? Yeah. Okay. Then we wanted to make it easy. So we wanted to be able to just open the box and have a great out-of-box experience with the minimum required background on how you can do it. We also wanted to make it fast. That means with Intel Joules, we are enabling rapid prototyping and faster time to market, and that was our main focus. We wanted developers to be able to go and start from rapid prototyping and then be able to do a product as fast as possible. And we wanted to make it your way. That means we wanted you to be able to use whatever operating system you want, kind of. Give you quite a few operating systems options, and wanted to be able to enable you to also have scalable hardware where you can expand the ecosystem to. And finally, we also wanted to make it real. And what we mean by real, we wanted a seamless integration with RealSense. So we can able to connect RealSense cameras to it. Questions? Okay. So here it is, the Intel Joule. I have the box here. It's already in the market. It's awesome. In a nutshell, what is the Intel Joule system on module? It's basically a high-performance system on module, integrating a complete computer system into a tiny package, enabling developers and entrepreneurs to go from concept to prototype to production products in a fraction of the time of traditional system developments. We also wanted to integrate features high-end compute and graphics. We want to have large memory and low power envelope, making it an ideal platform for innovative IoT edge computer applications and products requiring advanced computer vision. So here it is. It's a quad-core, 1.5 gigahertz or 1.7 gigahertz. It has the Atom CPU. It comes with 3 or 4 gigabytes of memory, 8 or 16 gigabytes of storage. It also has built-in Wi-Fi, Bluetooth. It has support for USB 3. It enables 4K video. That's for encoding and decoding. It has Intel HD graphics, and it ships with the Yocto built-in Linux, which is an open source version. Yes.
Are you going to do a compare and contrast between the Intel solution and other competing solutions that are already out there? Why prove to us why we wouldn't?
Pardon?
Okay. And but I mean, like Qualcomm and other ARM type solutions.
No, I'll just tell you how awesome it is,
Okay.
and then you do the comparison. Sorry.
All right.
Yes.
Is that the USB Type-C?
Yes.
Power requirements of that.
How much power? I think it's 4 watts on idle,
Okay.
and then all the rest depends on your workload. So, pardon?
You have 4 watts idle.
Yeah.
Okay.
Does it have the ability to clock down?
Yes.
Sorry. Go ahead.
Yeah, so can you talk at a very high level what the differences between Edison and Joule are? Because I see a lot of commonality between both the devices.
Okay, I have a table that actually shows that. It's not in this slide, but basically the Joule supports graphics. The Edison did not. This one is quad core. The Edison was not. What else? It's much more higher performance. This is what we're targeting. So with this one, it's specifically more for drones, for robotics, for machine vision, which is something more advanced than we were able to do with the Edison.
Is it 5 volts or 3 volts?
3.5 and supports 5. Okay. So basically, the whole size of the module is 2 quarters. So if you put 2 quarters next to each other, this is the size. And this is kind of the target verticals and the usages. So we want it for robotics, and that means what we envisioned as a key usages was like for obstacle detection, for collision avoidance, for scene analytics or voice analytics. Also, we are targeting unmanned aerial vehicles, UAVs, and then also the same thing, basically obstacle detection, collision avoidance. We also envision for industrial computer vision, or to create micro gateways in it, or even AR or VR. These are kind of what we thought, but this is not the limit. I mean, we're just giving suggestions, and it's all up to the developers and all these startups to kind of be creative and use it the way they want. Okay, now we're going to talk about the architecture and the base carrier reference. So here's the module architecture. Again, I'm going to open this Joule if you haven't seen it before. And I can pass it along if you want to show the box.
Thank you.
Thank you. So again, it has an Atom processor, the T5700 and the T5500. Basically, it's a quad-core 64-bit processor with up to 1.7 gigahertz. It also supports Intel Gen 9 graphics. It has 3 to 4 gigabytes of POP RAM on module. In terms of, it also supports Intel Dual Band Wireless AC A260. So we have built-in Bluetooth, Wi-Fi, and we also, and then of course we have the power management IC.
And how many GPIOs?
We're gonna go over that in a second. So, in terms of pins, we have 2 times 100 pin connectors. So we have one USB 3.0 on the go. We have the other one, the other USB 3.0 for PCI Express. We support also USB 2.0, SD cards. It has 2 digital mics. We have 5 I2Cs, 2 SPIs, and 4 UARTs. And we have up to 48 GPIOs with 4 of them for PWM. And this is like, we have plans like when, in terms of roadmaps, we aren't done. We have even more capability to be coming to the market very soon as well.
Is there an onboard DSP for GPU?
Pardon?
Is there an onboard, you said there's graphics as well?
Yes.
Is there access to combine GPU, CPU processing?
Combined what?
GPU, CPU processing?
Yes. This is basically the architecture. So part of enabling ubiquitous is driving smaller form factors. As I mentioned before, the size of this is basically 2 US quarters. So we have packed all this performance in this small space. I know you all want to look at the dimensions, so basically a 24 millimeters by 48 millimeters by 5 millimeters. And the 5 millimeter height also includes a thermal transfer shield for managing thermals.
Does that mean that you will phase out the Edison chip?
Not really. So it's different category of, I would call the Joule the Cadillac of Edison. I don't know if I'm allowed to say that, but this is what I feel. Like if I had to describe it, I would say that. And whenever, for example, when we first launched and we're thinking, hey, I have this project that was with Edison and I want to do it with Joule. Basically, any project that you can do with the Edison, you can do with the Joule, with the exception that Joule supports a lot more and you have to have, higher performance applications. It's for higher performance applications.
So Joule supports the Arduino, just like the Edison does?
I would guess not with the pin
Not
models.
yet. I'm not sure. I haven't even thought about it, asked about it. I haven't tried, but it supports. You can do so think about it. It's like a Linux system. So if you put Linux, so you can do C, C++, Java, Node.js. You can do Python, all this. But I'm not sure if Arduino per se was a goal.
How much is it?
As a
350 with a
Cadillac,
carrier.
yeah, that's an important question. Which is it?
350 with a carrier board, the the one that ships here. So the box that you see.
The development package is
Yes,
$350.
yes.
How much for the module alone?
I think it's 159.
That's almost a deal killer. Compared to other
I mean, that's the case.
IoT platforms out there, similar performance out of a ARM quad core can be done with GPU can be done for $35. Just my feedback. You need to bring the price down.
Okay.
Impressive specs though.
Is that with the 4 gigs of RAM, the 159, or?
Yes.
And what about more RAM? How much is it then?
We don't have more than 4.
Oh, I thought there was something where it said went up to 8 or something. Oh, was that?
That's a storage, 8 or 16.
And how much would that be?
It's so if we go 1 second.
And is that 8 or 16 flash on the module?
It's on the module. 1 second. So if you go to our site, you can say Intel Joule module. Okay, so it's 3. Screen, I can't see it. So what was your exact question again?
I was just asking, for more storage, how much is it? You said like 159 was the basic
So,
model,
so
right?
399 is for the entire developer kit.
And that's with the higher storage?
Yes.
Oh, okay, so it's like $50 more.
Yes.
Okay.
Okay.
And I think the development kit cost is not important, it's the module cost in mass quantity that's important to meet a price point.
Yes. So this is the base carrier that comes with it that you've seen. And basically, there's three purposes for this one. The first one is to connect the Intel Joule module to the base carrier board, break out the module's interface to user-friendly interface, and then the third one is to deliver power to the carrier board and eventually to the module. The shield can be attached on top of can be attached on top or bottom of the connectors. Basically, it has the DC in is 12 volts or 3 amps. In terms of USB connectors, you have one Type-C with OTC and one Type-A, USB 3.0. Multimedia, we support micro HDMI and MPI, MIPI DSI display interface. Basically, this module supports 4K encode and decode. It has also generic I/O connectors, so we have the 2x40 pins with 100 mils I/O connectors, and it has 3.3 volts, but also can tolerate 5 volts level shifts. Other things, it has a micro USB to serial FTDI for debug port. It also has SD card 3.0 compliance, and it has 4 general purpose LEDs and 3 buttons. And the most important thing is that everything is open source, so you can.
So is the BIOS open source?
Pardon?
Is like the BIOS of firmware for it open source? Like the firmware, like the BIOS thing or
Yes,
whatever?
yes, that is open source, and also I'm talking about the carrier, the schematics for the carrier. So lowering the barrier even more with an ecosystem for Intel Joule. So we wanted, our main goal was to make it your way. And by that, we actually, we support the UEFI BIOS. So we eliminated completely proprietary BIOS and moved to a more unified approach to the more industry standards. So, and then on top of that, what we have done is we put the Linux kernel 4.0. Out of box, it supports a reference Linux OS for IoT. So this is the Yocto based, and right now it's called Astra. We also support the Ubuntu core, and basically any Linux distribution actually, so not just that. And this is new to us. We also support the Microsoft Windows 10 IoT core for this module. So we have, what's that?
Boo.
Some people likes it, so we support it. And again, one of our goals was to greatly accelerate time to market. And before, you required a higher investment and longer time to market. So let's say you wanted to develop a product. What you have to go through is first have a concept, then design the compute and comes hardware. Then you have to write the OS level code, then you have to design and build custom carrier boards, then you have to get globally certified, then you can write your app, and then you can do produce and sell. What we have done is eliminated all these steps for you, and now the developers don't need to do all these. We have done them all for you. And you can see.
Are the 2 radios FCC certified?
Yes, yes. So with this, you can do rapid prototyping with a module dev kit, and then you can outsource your custom carrier board. Here I brought in some from Gumsting Shubato, where you can go to their site, and basically they already have the Intel Joule module specs and all that, and you can, using a drag and drop interface, you can decide how you want your board and all the connectors that you actually want for your carrier board. And then within 3 weeks, they ship it to you. Once you create it, they even create the documentation for you and the schematics and all that. And if you do not have a background and you don't know, let's say you put a connector and that connector requires an additional thing, then the system automatically will guide you on how to make sure that you're building the right design. So again, customization and scale. We're making it easy to make it your way. I went really fast. So on Friday, it was my first meetup here where we talked about in the Joule. This is very new. And I'm happy to let you know that we're also going to have a hackathon coming up from November 4th till the 6th. And basically, I'll be bringing in the hardware and all that. You guys can sign up on what kind of projects you want to do, and we'll try to accommodate those hardware to bring it in. But you feel free to bring your own. Before this actual hackathon, we're going to have another happy hour on the 24th. And I'm super excited about it. And then finally, again, we're making performance ubiquitous. Small form factor with big performance and features. We're making it easy so you can purchase in units of one and get going immediately. We're making it fast, so module architecture streamlines the development process. We're making it your way with a choice of operating system and carrier board. And we're making it real, so tight integration with Intel RealSense cameras. And I just wanted to also mention that when we were doing the Intel Edison, there's at least we support 150 different sensors and actuators through our open source library in RAW and UPM. The same we ported to Joule, so the same projects that you were able to do on the Edison, you can do with a Joule, and we support all this, so you don't have to learn about it. Yeah. Questions?
What is the price for Intel employees?
I pay the same.
Same?
Yes, I was.
You get a discount?
No, I pay the same. I think yes, it's the same.
Grace, I'm very impressed by the module. I can tell you from my study and experience that this is the state of the art in computer on module or system on module.
Thank you.
I'm very impressed.
Thank you. I told you it's a Cadillac.
But and for those high-end applications like drones and robotics, maybe $159 is sustainable. But for the broad consumer marketplace, for consumer type devices, that's not a viable price point.
And that's why we have the Edison. Because the Edison was also, the Edison's also used in drones and other stuff. For example, Dronesmiths, they have their drones and they're all built on the Intel Edison. There's quite a few other companies that have like that. So this is for much more advanced. We know the price point is not cheap, but it depends on the product that you're making.
If you're the evangelist for the company, I presume you have a dialogue with upper management. My suggestion is they come up with a Chevrolet version.
Well,
that scales back just a little bit.
we start with the Arduino. We have an MCU, so we have the Arduino 101. That's based on the Curry, and then we have Galileo, which is cheaper, no built-in Wi-Fi, for example. And then you move up and you have the Edison, and then from the Edison, that's Joule.
Something in the middle, maybe 1 gigahertz, dual core, 2 gig of RAM would
Okay.
fulfill most consumer applications to bring it in about $60.
Okay.
It would be it would take over. And the timing is good. With SoftBank's acquisition of ARM, I think ARM.
Does Intel have any plans for something like, well, I guess, actually, I'll take it back. Movidius just got sucked into the solution, into your solution. So when do you expect those kinds of technologies to play out? Do
We
you
will
think-
be announcing whenever. I'm not sure. I don't know. Sorry.
Oh, because, I mean, that could really change the game if the application space is for real sense and for vision type, computer vision.
So right now, so for example, the Joule, you can do the R200 with it, the R300, all these, you can use RealSense with it. So, but I'm not sure exactly what exactly you're looking for in your question.
Oh, and I will, Movidius, which obviously can be built with an application processor right next to it, and can play the role on a drone, just like maybe this modular system could do. So I guess I was trying to imagine, do they expect that this would be paired with a multimedia processor, like a vision processor? Or is that gonna become a competing parallel product inside of Intel? What does that look like?
I'm not sure. I don't wanna give you just any answer, I'm not sure, I apologize.
Do you have any use cases for the Joule online that we can potentially look at?
Use cases like products that's been up.
Like any specific applications that customers have used the Joule for?
Means just 6 weeks in the marketplace, I would guess not.
Well, so we were we launched it at IDF, and during the keynote at IDF, they actually had, let me grab you that picture of that demo. So we worked with a company called, that's not me. We worked with a company called V-Stone. I'll tell you about it in just 1 second. And I'll tell you about that project. Okay. So this is V-Stone Soto. It's a bartender robot, and basically they were able to build this prototype within 6 weeks, as we were also doing the development for the product, right? So this is basically a Japanese robotics company, which partnered with Intel to build the next generation of commercial robots for business-to-business services. Basically, what this robot was able to do is, if you talk to it, first of all, it can track where you are. It can, so when you come in, it can determine through the RealSense camera that you came in. It can take your order. You can it's integrated. You can speech, so you can talk to it and request a drink, and it will give you that drink. And it can recognize objects, and it can allow interaction with customers. That's one example. I have an innovator that what he did is create a robot. They just showcased it at Maker Faire in New York, and basically created a robot where he can take pictures. It's a warehouse scanners, so it can check out a warehouse, and it can check out the products that are there. It can learn what these products are, so if it doesn't identify it, you can train it, and then it will add it to the inventory. And once this, and then it can learn, let's say if over time you're replenishing your inventory quickly, it can predict like how fast you need to actually add more products to your inventory. So this is one example of projects that's been done. I know they're using it in drones as well. And we're building the ecosystem. Part of what we've done before with the Edison is that we encourage a lot of developers to share their projects on Hackster.io or Instructables or various different means. And we'll be doing the same sort of efforts now so we can have more examples for developers. But again, this product is targeted for more advanced than just regular tinkering makers.
Do you also plan to give free samples away during the hackathon?
No. That was hard. What I mean is, I'll be bringing in the hardware with me, but we're gonna take it back. The winners will get to keep the hardware.
So you said it uses 4 watts of idle power. That's on the high side for most embedded devices, and this would not be suitable for a small battery-operated device. A large battery perhaps, but I think most applications are gonna require line current. What is the operating temperature with such a high power, or the ambient operating temperature with and without fan?
I don't have the results of these studies yet. So they have done some, and we're planning to publish them, but I don't have that information yet. But if I take your contact information, I can send them your way. I think, yes.
I think the primary selling point for this, the Intel Joule, is its compatibility with the Intel RealSense.
Absolutely.
Because, my issues and point of contention is the number of platforms that aren't available that's compatible with RealSense that needs to be pretty large, like a desktop computer. And what Intel Joule does, it puts it in such a small form factor and offers that USB 3.0 connectivity for the RealSense. Whereas with the Intel Edison, that does not have USB 3.0 compatibility. And so when I'm using the RealSense, I could either use the Intel Joule, or there's also an alternative, which is the Upward, but that also has the Intel Atom processor with the USB 3.0 compatibility.
That's right.
I agree, it's kind of a no compromise approach. This might save the company.
So, there's lunch over there. I'm still gonna stay here. I feel bad if it's gonna get cold. Feel free if you wanna grab something, but we can keep talking. I'm here.
Where is this product developed?